Alright, so since this has been requested several times now, here is my internal ELRS mod for the Tango 2. So yeah, I already started disassembling it. You know how to go this far, right? Here you have the grips, you grab with your nails by the edge and you start gently pulling out the grips. Then you have 6 screws to take out. And here you have your main board. We'll get to that later. We're gonna first get deeper into the module, and for this you need to remove the battery, which is just held down by this dual lock adhesive. And yeah, so disconnect the battery, you disconnect the screen and the speaker right here. Make sure that you do this so that you don't break them when you take out the board. And then you only need to remove these screws here, there, and this one. You don't have to remove these screws here. These only hold the gimbals, and if you remove them, you're gonna need to recalibrate your gimbals. So now that we've removed this, we can take apart the main board. Ooh-wee. And this is where I put the module. This is just a Radio Master Zero internal module. This is what they look like. It's a spare part from Radio Master. Comes like this with this cable that we're not gonna use. It's a pretty neat module. It's 250 milliwatts, but it has everything on board. It has the backpack, has Wi-Fi connectivity, so yeah, it has all the features that you would want from an ELRS transmitter. To attach it to the board, I just cut a couple strips of VHB. I think I can insert the picture in there to show exactly how I put it on there. On it to the highest point, so that then it fits exactly on the RF shield of the Crossfire. That was the best way I found to install it. That leaves the heatsink exposed for this board, and we have the apex that goes up the top. So that's just the way that made most sense. And yeah, this module actually has the pads broken out, so we just use this to break out the wires that go on the other side. So now we get back on the board and we're gonna have a better look at the power delivery, which is the most intricate part of the build. Okay, so here you have your wire that comes from the module, and it is broken out as follows. So I soldered it directly to the FPC connector, and so you have RX and TX that go to these connectors. I think I'll just edit in the pinout. Yeah, I just soldered it directly to the FPC connector. It's a pretty delicate soldering. I wouldn't know where else you can install it. Might be some test points on the other side, but yeah, this worked well for me. And so here goes the UART, and when it comes to power, I'm using this Boostybaby. That's a voltage booster that I've developed initially for 1S HD 18650 builds, because it can power, yeah, it can deliver 5 volt at about 2 amps all the way down to 1.8 volt. So it will boost as low as 1.8 volt up to 5 volt, and yeah, that will provide us really steady and reliable power to our module. Yeah, the reason I had to do that, I'm going to zoom in a bit, is because this FPC cable only outputs battery voltage through this fuse here. So there is a fused output for the module, and if you get the TBS module bay adapter, it does have a 5 volt booster on board that does just that on there, because your ELRS module is gonna want 5 volt. Initially I put it here on this 5 volt pad. I've tried to power the module directly from 5 volt, but the issue with doing it this way, that simplifies everything a lot, but the issue is that when you don't use your ELRS module, when you only use the internal Crossfire, this will remain on permanently. it's a bit wasteful, and yeah, this is why this functionality is added onto the TBS module board add-on, which is the enable feature, which is used by the Boostybaby. So so we have our UARTs, and right here is the enable pin that is wired directly to the enable pad of the Boostybaby. And the thing with the Boostybaby, you can see that it's actually a inverse enable. So the enable on the IC is permanently enabled, but it's pulled high by this resistor right here. So I have this resistor here that pulls the enable high. I think it's a 1K resistor to keep this enable pad from floating when not in use. Yeah, the way I wanted this to work with the enable pin is that most people are not gonna use it, the enable feature, so I permanently enabled it. And if you want to use the remote enable feature, for instance on your flight controller, if you want to have the ability to turn off your VTX or whatever accessories you have on the Boostybaby with an aux mode, like basically on a switch with your remote, you will wire it as a feature that is called true pit mode. Yeah, it basically will pull this line low to ground, thus disabling the Boostybaby. Anyway, for this purpose, we actually, if we keep the resistor in place, yeah, there is a chance that when the enable is grounded, that if there is not enough resistance in this enable circuit to effectively pull the Boostybaby enable line low. So yeah, I could have measured it. Actually, maybe it's not necessary, but yeah, just in case, I disabled the pull-up resistor. So here I just desoldered and put it at 90 degrees on the pad so that I know where it is. I can keep it if I want to reuse it later. But yeah, if you want to do this mod, you can just as well use a soldering iron and use a blob of solder, connect both ends of the resistor, and it will stick to your iron, and it will be removed just as well this way. So yeah, that's the only complication to this build, that you need to basically remove the pull-up resistor, connect the enable of the Boostybaby to the enable of the Tango. Well, this now allows the radio to enable or disable the external module, or the ELRS module, whether it is selected in FreedomTX or not, instead of leaving it permanently on. And so then the Boostybaby, it's very simply, I connected the plus of the Boostybaby to the fuse, because it is there, why not? And the ground, just connected to the closest ground available, which is one of the pin of the USB-C. Then the last thing from here is the antenna. The module has a IPEX UFL connector right here. And so yeah, you can connect any 2.4G antenna as you wish. One way that you can use that is very simple. You can just use one of these RX antennas. You can literally thread it through the stock antenna and attach it to the back. If you want to be even more sophisticated, the shell of the stock antenna is ultrasonic welded, and there is actually room for an antenna like this to fit inside the shell. So if you wanted to go really neat and stealthy and keep the most range, you could totally split the antenna open, insert your 2.4G antenna, and slide it through the pivot back into your module, and then glue the antenna back together if you can manage to split it cleanly enough. However, what I used is one of those PCB antennas. internal PCB antennas. And I took mine, I just stick it to the top of the case like this. And yeah, these are antennas that I had from the X-Lite module that I've had running in my FreeSky X-Lite for a while. And yeah, they've been using this type of antenna inside as well, and it works pretty well. And for the range that you want to expect anyway, I mean, at least in my use case, which is mostly now for whoops and park flying, anything else, anything longer than that, I'm just gonna switch to Crossfire. So yeah, this was the minimum invasive way to add an antenna, 2.4G antenna to this setup without having any minimum obstruction from the outside. And yeah, that's about it. So all you need basically for this mod is your Radio Master module that fits perfectly between the gimbals. You need a Boostybaby, an antenna, and that's basically it. You could also, of course, use the external module kit from TBS. Yeah, this could be a less difficult soldering job if you don't want to solder to this. You could also, yeah, simply use this module, somehow pop it in there and use a external ELRS module like this. Although keep in mind that if you use the TBS module, yeah, the power is pretty limited. I reckon it's not recommended to go above 250 milliwatts of output power. And if you use the TBS module, which has S-port, you'll be also limited in packet rate. When I tried, it was like 333 with Freedom TX. Things might change with HTX, but yeah, for now these are the limits. So yeah, another benefit of using this internal module with a full duplex serial is that you can unlock faster packet rate. So this enabled me to bump it from 333 to 500 Hertz packet rate, lowering latency and whatnot. So yeah, so this is what I've been running. It's been working flawlessly. Boostybaby is holding its weight, and yeah, by installing the module as I did, you should also be able to see the LED of the ELRS module through the top of the radio to confirm that everything is working. So yeah, it might not be the easiest of mods, but I'm pretty happy with how stealthy and integrated it ends up. And yeah, from the moment you solder the UART properly, it just works right out of the box. And that's about it. I hope that this clarifies how I made it work. I think I'm just gonna play a little slideshow with HD pictures of the installation earlier, as done as I done it the first time. And yeah, hope that this was helpful to you. And I'm gonna reassemble my radio and hope I never have to do it again. Alright, thanks for watching, and happy flying!